Yeah, good morning, everybody. Last date for Christmas, and as you hopefully have heard yesterday, or that you got an email that I uploaded you in the exam Moodle room. Yeah, and therefore, please then log in the following Moodle room. You see here Fachbereich Wirtschaft und Gesellschaft, Hausarbeiten, and then my Moodle room for this exam. There I uploaded you, and here is a function test that everything is technically working. This you should do. And after you have done this and you have declared that it is possible for you that you can do the exam, then afterwards you see here on January 20th it will be possible that you download the tasks I will give you at 20th of January, and then you have 5 days doing your exam and just upload it. And please only upload one PDF file because afterwards I will have around 100 exams, and then if you upload, everybody is uploading 5 to 10 single sheets. Just to open these sheets will take then 3 days. So please only upload one PDF sheet. I will give you also some hints how you can create one PDF file. Yeah. Okay. Here, there you can here to the search part, or you can also, if we take this here, the starting page of Moodle, and then you find here our Fachbereich, and then it is down here, the last one. Click on this, and there, since I'm the only one doing this here, then you find the Moodle course. Okay. Yeah, but maybe I will send you also the direct link. That's a good idea. Okay, the last years it made no problems from the technical side to do this. So I had a participation quote of 100%, no dropout the last years. Okay, and then about the exam in general, let's go here. Yep, yep, yep. 20, 21, 22, 23, 24. Yeah, it's opening at 0 o'clock, so it's 5 days or 4.5. Okay, I have it to admit, 4.5. You're right. And what I wanted to do, yeah, this one here. So I have also uploaded you the review questions, and in general, the tasks I will give you will look like these tasks. Maybe I will not give you some tasks like this, just defining a variable. There, I think I will just vary it a little bit. But in general, you can rely on that the tasks will look like these review questions. And what will be different is that everybody of you will get one specific country in the world. And in a minute, I show you how you get data from this country. And there, I think I will ask you to roughly describe the economic performance throughout the last years of this country. And this will be done via the IMF data. So let's go here, and I write it also down here. Boop. Country data, IMF data mapper. So International Monetary Fund, there you find data from every country of the world, and the link for it oops, is this one. And let's also do it that you see the syntax. And then clicking on IMF data mapper, then you see in general directly you will be linked to the real growth rates of the countries in the world. Then you see here a direct selection is the aggregate of emerging markets, advanced economies, or total world growth of real GDP. And then you find here via data sets a link direct to the actual data of the World Economic Outlook. So then click on data sets, or the first one I think was IMF data mapper. Yeah. Then click on data sets and choose World Economic Outlook. And then you find here downward different aggregates. So real GDP growth, GDP at current prices in US dollars, GDP per capita in current prices. Here purchasing power parity, this we haven't done in our lecture. This more or less means that due to the exchange rates you can think of, that going to a supermarket in different countries, you take, for example, 1,000 euros in Germany and going downward to Wilhelmshaven, and with 1,000 euros you can buy 10-liter milk, 5 kilo of butter, and so on. So this representative basket. And if you think you just take the actual exchange rate, let's say to British pounds, and then British pound, what kind of exchange rate do we have? £1. So you will then have roughly 800 British pounds, and going with these equivalent kind of money into a supermarket of London, then of course you can think of that you can buy much less than here buying in Wilhelmshaven in a supermarket. And this effect, this is called the so-called purchasing power parity. But only that you know it, I won't ask you something about purchasing power parity. But if then maybe I ask you, please describe the nominal development of the country, then of course you have to choose here GDP and current prices. Yep. Okay, then here we have the inflation rate, or we have population, we have the unemployment rate, current account, and general government grow debt. So all these aggregates we have talked about, especially when we have looked at the magic square and when we discussed which are the main um, indicators of a country. So these general data you will find here, and I will give you a task to describe some kind of these data. So for example, oops, then choose the asked parameters. For example, real GDP growth. Where we are here. So then click on this, and let's say you have Brazil as a country. Then first delete this one and choosing here, where is it? Brazil. Then you see down here, Brazil is also selected. Well, this we cancel again. And no, it should not Argentina, but oops, this one we do not need. Why isn't it shown here? Oops. So now you have to reload the page, and then you see here you have the direct graphical representation of real GDP growth. But I will ask you to somehow manipulate this data or choosing another time frame. And for this, you can download down here the Excel file. Let's take this on the desktop. Where is it? PC? No. Where's my desktop? Anyway, then let's go down here. Well, I just rename it to Brazil. And so download the data in an Excel file. And where we are, I think just here. And now you can open the data. And well, of course, you can then choose the horizontal. For myself, I take in general the vertical representation. It's for me a little bit easier. There you can transpose the data just here, and oops, this one I want to, so. And maybe I ask you to represent the data since the global financial crisis, so beginning at 2008 maybe. Present the data since the global financial crisis, 2008, and what you can do then is taking this data and just around here you find to present the data, maybe in line. Now we start at 2008, 1980, and going down here, then we are starting. No, why not? Sorry, this hasn't worked anyway. So then you can also right click in here and 2008 is 31. So here typing in 31, and of course also the horizontal axis, and then you have the presentation. No, something is wrong today. Oh, here from 31 to the last one is 52. This one, 31 to 52. Now we are starting at 2008, but of course here you have to be careful that the time series is going up to 2029, and this means the data includes also the forecast of the IMF. But this I will give you then, of course, in the task. And let's say that from the financial crisis up to the actual data, so until 2023, this is the last data point. Oops. And this would mean we have to cut off at 46. So no, it won't. It won't be. So we have a quick estimate for Germany, and we are very, very fast in the midst. I think around the 20th of January. But this is only a quick estimation for Germany, and most countries you can think of, emerging countries, countries in Africa, also on there. It will be. It will take longer. Yeah. So then 46. So this may be then just that I want that you give me this representation. Maybe I ask you to roughly describe the economic performance. So this is then that maybe you see something like the business cycle within your data, or if you don't, because I don't know which country you have, and I do not have every performance of every country in the world in my head. If there is something special, maybe in 1 or 2 sentences, you can describe this. So here for Brazil, we can see after the global financial crisis, we had here a quite high growth rate, and then during 2014 to 2016 with negative inflation, real growth rates. So this would be then something like the recession within the business cycle. So maybe something like this. And maybe then I also ask you what was within this time frame 2008 to 2023 the average growth rate of Brazil. And for this, maybe you know how can we average growth rates? What do you have to do? So maybe another task would be calculate the average real GDP growth rate from 2008 until 2023. What would you need to do? Let's take this downward here. Yep. Yes, but not the geometric mean of the growth rates, but the geometric mean of for this you would need the growth factors. Remember, what would be the task? We have starting, let's say, GDP at 2007 would be 100, and then the development over time until GDP 2023 would be then 100 times 1 plus the growth rate, 2008 growth rate, 2009, and so on, equals 100 growth rate, 1 plus the average growth rate, which you need up to the power of 23 minus is then 16, 1 over 16 over these years. And therefore, then you obtain average growth rate as all these single growth rates. Oh, sorry, not to the power. This is to the power of 16. And then 1 over 16 minus 1. So, and here you have the growth factors. So then we would need the growth factors, and there you have to be a little bit careful because here the data is given in annual percentage. So the growth factor would be then, oops, well, let's take every growth factor, would be then 1 plus 9.2, oops, equals 1 plus 9.2 over 100. Okay, this you should also know from your mathematics courses. This would be then all your growth factors. And now, then what we would need is equals the product of all our growth factors to the power of ending minus starting plus 1. Oops. And 1 over, I forgot. This would be then the growth factor, and the growth rate would be then this minus 1, and in percentage you have, up, is not working, then maybe somehow this percent, and this would be then the average growth rate. Or maybe you also know this, hopefully this works. You have a direct function, of course, in Excel. This you also can use the geometric mean minus 1, and here you see that of course we have the same. Or what you also can do is of course typing in your calculator by hand and calculating the product. How you do it anyway. You can really use of course also the software packages. Yep. Calculate. Okay. So maybe then and oops, average growth rate from 2008 to 2023. So something like this you should do. So what you can do, for example, in advance, that you go to the page of the IMF data mapper and just try to download some data. And also just try to create such a diagram. But hopefully in other courses you also have already used Excel or some other software packages. Maybe, okay. It won't be that much what I will, and you see it is not that hard here. Just up here you can use your representation of your data. Just try it. this would be also a good thing if you practice this not only for this exam, but for your general competences. Okay, so then let's go to some other tasks I wanted to do with you, also the Keynesian commodity market. Oops. So within the Keynesian commodity market, we have autonomous consumption of C0 is 30 and a marginal propensity to consume of 90%. Investments, we have 70 and government expenditure 50. Determine aggregate demand. YD is in general. Yep. Yes. So what kind of aggregates in general we have to sum up? Yeah. Yeah. Government. So I had, as you said, and this was the consumption. So, and then if you keep this in mind, this was also from the expenditure approach. Remember just in the beginning describing GDP expenditure approach, calculating GDP means that roughly we look at the demand side of the economy. Demand side, this is the expenditure approach, and then we just set in the data we have is 30 plus 0.9 times y plus 70 plus 50, and then of course we can sum up the constant parts to 150 plus 0.9 y. Second one, determining the equilibrium income, which kind of condition for equilibrium we have to use. Idea? Yep. Yes. Yes. And so this is then just the function y equals y. Huh? So this was this 45-degree line, and then yd equals y. So this is the equilibrium condition. Yd equals y. This of course then means y equals 150 plus 0.9 times y. Solving for y, what we have to do? So yd is starting here at 150 with a slope 0.9, so it is a bit flatter than yd equals y. And now we have to solve this equation. This is just calculating the cut of two linear lines. Class 7 or 8 in school. Yep. Why does it help? Then you have on the left-hand side 1 equals 150 over y plus 0.9. Well, you can do it, but this doesn't help. So minus 0.9 times y on both sides equals 150. Here you have this 1. Then we have y 1 minus 0.9 equals 150. And then y star is 150 over 1 minus 0.9. This is dividing by 0.1, and 1 over 0.1 is 10. So we obtain 1,500. So determine the effect of doubling government expenditure. What happens then? And what do I have to do? Yep. Yes. Let me take this in red. So this one is going up. G is going up. And then we have delta G is also 50. And let's say it's G prime is now 100. So then we would have YD is 30 plus 0.9y plus 70 plus 50, plus 50, and this would be our delta G. And so we obtain YD, as you said, is 200 plus 0.9 y. So this is moving up by 50 to 200 parallel. YD prime is 200 plus 0.9 times y. Well, and of course, then I can redo all the calculations. Y equals YD prime, but as you said it, here I have plus 50, here I have 200, here I have 200, this would be 200, this would be 200, and this would be 200. 200 times 10 is, of course, then 2000. So in your exam, you can do it like this. But please do not only write down then, well, I know it, and just without anywhere marking what you are doing, just now the equilibrium income is 2000. It is more or less everything okay if your result is right, but if your result wouldn't be right, so you only made some miscalculation, and if I then see only one number, then I have no clue. Have you only made a calculation error and your answer is correct and you have understand the model if you haven't written down anything else? So just mark me at some point what you have done. Okay. Also, what we discussed on Tuesday. If I want you to calculate some growth rates, please do not give me only your results. Also write down at some point what you have done. Because then if you miscalculated at every point, then I can see, well, it's not 10 points, but it's still 7 points or something like this. If I see only a wrong number, then I have the problem to give you some points. Okay. So, determine government expenditure multiplier via the geometrical series and the solution of the equilibrium condition y equals yd. This was 1,500 and this was 2,000. So, what was the argumentation via the geometrical series there, so to speak, in, oops, let's take green. T is 0, we have an increase of 50. This translates in a push on production of 50. So then we had the push via the consumption. There, this plus 50 is feeding in. Okay? So delta C1 is 0.9 times 50 is 45. Consumption is a part of total demand, so it also pushes total income by this number. So Y1 is 45. Again, these 45 is a new income, and 90% of this 45 is also consumed. So delta C2 would be 0.9 times 45 is 40.5. And this goes on theoretically to infinity. So in general, we obtain 50 plus 45, total change in income plus 40.5, and so on. This we can write as 50, 1 plus 0.9 plus 0.9 squared, and so on. This is a geometrical series, and from this we know this is 1 over 1 plus 0.9 is 10. Government expenditure multiplier. Or how can we also do this? Well, here, or better, this one. If we take this equilibrium condition where we have solved already for equilibrium income using the parameters and not the definite numbers, we have y star is C0 plus I plus G over 1 minus marginal propensity to spend. And then we can ask what happens to y star if we are in general change government expenditure by 1 unit. And this means mathematically nothing else then to take the first derivative of equilibrium income with respect to government expenditure. So then dy star derivative with respect to government expenditure. Maybe it's better to write this also like this. Plus g over 1 minus c y. If we take the derivative with respect to capital G, then this we just treat as a constant. What is the first derivative of a constant? Yep. No. So f of x equals 3, then f prime of x is so the first derivative is representing the slope of the function in every point. How does a constant look like? F of x, and if it's 3, it's just a horizontal line. What is the slope of a horizontal line? Nothing, just 0. So then this part vanishes. And what is the first derivative of this part? This looks like f of x is 1 over 1 minus 0.9 times x. What is the first derivative? Hmm? Constant times the variable. Or f of x is 5 times x. What is f prime? What's about the internet? Yep, it's just 5. It's just the constant. And the constant is here now 1 over 1 minus the marginal propensity to consume. This was 10. So we are left with 10, or in general with 1 over 1 minus marginal propensity to consume. And this is, of course, the same result which we have got taking this process via the geometrical time series. Not time series, via the geometrical series. So I really recommend that you see or you learn again the first derivatives of simple functions. Well, of course, you have 4 or 5 times. You can, of course, also use some software package. This I would also recommend that you use these things, because calculating the first derivative of some more complicated function, this will really take some time. You can also use, for example, the maybe most powerful mathematical tool in the world. This is the web front end of Mathematica, maybe the best mathematical program we have. And there, of course, you can calculate the first derivative of, let's say, 10 times x enter, and then you get the answer. But of course, as always, using software, using artificial intelligence, using some data programs, you always have to know what you are doing. Okay, so next one. ISLM. So now we are adding here the money market. This is the commodity market. And this is the money market. The first one, show formally that average consumption is falling with increasing income. Well, we have C of y is 5 plus 0.75 y, then average consumption is C of y over y. Inserting this, we obtain 5 over y plus 0.75 y over y. This cancels and we end up with 5 over y plus 0.7. Well, if I pose something like this, then of course you can argue this is dividing by the variable falling in y. Dividing by a larger number means that the number goes down. This is a constant, so it doesn't change. So in general, I see by just writing down and arguing a little bit that this is a falling function in income. Or what you also can do, if we call this average consumption, is of course by itself a function of income. So, or taking the first derivative, AC prime of y. So what is the first derivative of this function? 5 over y plus 0.75. Again, this is a constant. This vanishes. But what is the first derivative of 5 over y? Or in general, what is the first derivative of 1 over x? F of x equals 1 over x. F of x, 1 over x. What is f prime of x? Class 11 in Germany, I think. Root. Well, what we see here is really a pity. I have 3 kids in school right now. And I see that it is definitely not your problem that you don't know this. Because we are, since roughly 10, 15 years, at least in Germany, we don't show our kids anymore. I have to admit, simple mathematics. This is really a pity. So this is also x to the power of -1. What do I do if I have x to some power? Writing the power in front of it and decreasing the power. Of course, f of x equals x to a, then f prime of x is a times x a minus 1. You remember this? So -1 in front of it means minus, decreasing by 1 means -2. So x2, so -1 over x squared. So here we obtain -5 over y squared. Square is always positive. 5 is positive. Have a minus sign in front of it, so this is negative. What means a negative first derivative for a function for its monotonic properties? Well, for this we again have to know what is the first derivative. The first derivative is representing the slope of the function in every point. If the slope of the function in every point is negative, then of course it has to be a falling function. So monotonically decreasing in y. Okay, now I have to speed up a little bit. Determining IS and LM curve. Of course, for IS, we need again what we have already done, the equilibrium at the commodity market. So YD equals Y. Then we again set in C plus I plus G is 5.075 Y plus 5. And now, since we add the money market, we introduce also the interest rate minus 100I plus G equals Y. Then, here we obtain 15, subtracting on both sides again the variable part of the consumption is 15 minus 100 I equals 0.25 times y. Multiplying by 4 means 60 minus 400 I equals y. This would be then our IS function, I and y, and then we see for I equals 0, we obtain a y equals 60, and y equals 0 means 60 is 400i, dividing this 23, so 3 over 20, then I is times 5, 15%, I think. Hopefully I'm right. these are the two cuts, and then this would be our IS curve. So LM curve means money supply, nominal money divided by the price level equals L D of IY, money demand, and putting in this means 50 equals 2y minus 200i plus 200i is 50 plus 200i equals 2y, dividing by 2 is 25 plus 100i equals y, and then this is our ML function. For I equals 0, we are left with 25, so roughly here 25, and a slope of 100. This slope is relatively smaller than the 400, but be careful, as we do it quite often in economics. The y, the single variable, is now here on the horizontal axis. So again, we have interchanged the axis. So if we now want to draw our LM curve, then of course we have a steeper LM curve compared to the IS curve. And the slope is 4 times steeper. So maybe it looks roughly like this. IS. So determine the overall equilibrium. This, so to speak, means equating both equilibrium conditions at the commodity market and the labor market, and we obtain then 60 plus 400i equals 25 minus, sorry, plus 100i plus 400i and minus 25 means 35 equals 500i, and dividing by 500 means then 2 times 35 over 2 times 500 is I. Why? I have multiplied this by 2 to obtain 70 over 1000, and 70 over 1000 is of course 7% as an equilibrium interest rate. So I was quite good in drawing because it should be roughly half of the vertical axis cut of the IS curve. I star equals 7%. How do I obtain equilibrium income? Well, just putting in LM curve or IS curve. So 60 minus 400 times 7 over 100 is 2832, or hopefully it will be the same, 25 plus 100, 7 over 100 25 plus 7 is also 32. So here we obtain equilibrium income. Determine the increase of equilibrium income if government expenditure is increasing by delta G equals 1. Well, what does this mean compared to the other calculation? Well, the same as we have done it in the pure Keynesian commodity market. We have just to change the variable of government expenditure. This was this 5, this is now 6. Where do we find it? 5 plus 6 is then 16, and 16 times 4 would be 64. In the LM curve, nothing else changes, so then we find here a 64, and this means then we obtain here 39, 39 and 7.8%, and 7.8 7.8 means then here 32.8. What happens in our diagram? Well, in our diagram, you see here just an increase to 64. The slope of 400 is not changing, so it is just this parallel outward shift of the IS curve. IS prime of delta G equals 1, and this is then I star prime 7.8%, and Y star prime is 32.8. If we compare this with, oops, with the pure commodity market, then we know pure commodity market, what did we had? We had the government consumption multiplier. This was delta Y star over G. In general, it was 1 over minus the marginal propensity to spend. In our case, 75%, so the multiplier is 4, and then we would have an increase to increase of Y with 4 times delta G is then 4. So what we have here is that in this case, we had delta y is 0.8, an increase of from 32 to 32.8. And if we wouldn't have the recoupling with the money market, we would have had an increase of 4. What does this mean? This is the so-called crowding out effect. Because the increase of government expenditure is, so to speak, a rival to private investment. And since via the money market now the interest rate is increasing from 7 to 7.8%, this decreases private investment. And so the effect is shrinking from 4 to 0.1, 0.8. Okay. Crowding out effect. Then let's go to, suppose the central bank increases nominal money by 10. Delta EM equals 10. So then what we find now is in the money market, we have 60. So 60 here, 60 divided by 2 would be 30. Then here we have 30. And now you have to be careful. We are now not looking at the already increased G, but only at the former IS curve. And this would then mean we have 60 minus our new 30 on this side. So we obtain then here a 30. This would be 30, and here we will have 6%. So I star is then 6%, and putting this into the IS or LM curve would then mean, if we take here, the 6 is 60 minus 24 is then 36. Here we have a 30 and here a 6. 30 plus 6 is, of course, also 6. So double prime and y star double prime is then 36. In our representation, this would mean that we have a rightward shift of the LM curve here. This 30, now our curve doesn't start at 25, but it starts at, parallel it should be. At 30. And then this would be 6%, I double prime, and this would be 36. So F explained graphically why, starting from the pure commodity market model over ISLM to ASID, the impact of fiscal and monetary policy becomes less. Well, this we have already talked about. So in pure commodity, we have the direct impact via government expenditure multiplier. Then in the ISLM, the effect is dampened via the money market and due to increased interest rates and in the ASAD model additionally also the price level is increasing and therefore dampens the effect. Okay, and the graphical representation we have already made. Okay, well, I actually also wanted to do with you the neoclassical model. But do I got this? Well, this would take, I think, at least 15 minutes. Do you have time for this? Okay, then I hopefully do not miscalculate. I take my sheets of paper. Pardon? No, it's the second page. Second page. Yeah, it's just the second page. Everything is also in English. So then let's take this one. Oops. And since we are now in the neoclassical model, now we have again to deal with first derivatives. Because neoclassical view on the economy means always these homo economicus, rational, profit and utility maximizing processes. Maximizing means always analytically writing down your aims. These are functions, profit function, utility function, and then we have to take the optimum. Okay. Then let's go through it. So, neoclassical model. We have consumption spare time, function c plus 2 times square root of f. And as we have done it in the lecture, we are assuming for labor supply that we are spending all our labor income for consumption. So, labor supply means consumption spare time optimization. Yeah, but yeah, I recorded and yep, okay. So what we have to do is also our spare time and our working time is adding up to our full time we have. So we have L bar is the time sitting at the beach, F plus the time L we are working. This is our general restriction. And the other one is total consumption expenditure, price times consumption equals our working income, wages times labor time. Putting these two together, we obtain L bar equals F plus P over V times C. So this is P over W, sorry, not V, times C is L, and this we are feeding in here. And then what we have to do is maximize C plus 2 times square root of L subject to L bar equals F plus P over V times L. Well, then you have to remember your microcurves, the Lagrangian function. L is then C plus 2 square root of L plus lambda F plus P over V times L. And now you have to take the derivatives with respect to consumption, to spare time, sorry, and with respect to lambda, which is just the restriction itself. So dl with respect to c, if I put in front of here a 1, the slope of c is of course just 1. So I left with 1. Sorry, this is, of course, what did I do here? C. Sorry. Plus, what should I do here? PC. Oh yeah, this is all right. So, and then I only find the C in my condition, and I'm left with lambda times P over W. This has to be 0. Then, with respect to spare time, the first derivative of the root, f of x, is square root of x. What is f prime? This is also 1x to the power of 1/2. So 1/2 times x minus 1/2. And this is nothing else than 1 over 2 divided by the root of x. So I obtain 1 over root of spare time plus lambda equals 0. Oh, sorry, I really did something wrong here. It took too long today for me. Here I missed something. This has to be then, of course, L bar minus and minus. Then I obtain here a minus and I obtain here a minus sign. This means then 1 is lambda p over w, and this is 1 over square root of f equals w, and from this I obtain lambda is real wage, and so I obtain f is real wage. Squaring both sides means 1 over f is real wage squared. So I obtain f is 1 over real wage squared. And then, of course, I know that labor is 1 minus not 1 is L bar minus F. So L equals L bar minus 1 over real wages squared, and this is then our labor supply function. So then this is A and B. We have what else? C, labor demand. Via profit maximization. Maximization. So profits are in general yep. Yes. So and revenue is just our P times Y minus costs wages times L minus interest rates capital. So this is cost and this is revenue. And then we just put in our production function. So we obtain P times 2 square root of KL minus WL minus IK. In order to obtain labor demand, what do we have to do? We have to maximize our profits with respect to the labor time. So we have to take the derivative of the profit function with respect to L. Max profits depending on labor. So dL dP with respect to L. Then we have again 2 pi. This k is treated as a constant. So we have also square root of k still. And again, we have then just f of x is square root of x, or in our case, f of L is square root of L. So again, over 2 square root of L. Here, k is again a constant with respect to L, and we are in a fully competitive market, and therefore prices are also treated as constants. So this is a constant, and a constant derivative of a constant vanishes again, and here we are just left with the wage rate. So minus W equals 0, and then we obtain this cancels. We W over P is square root of K over square root of L. Again, we square both sides and we obtain W over P is K over L, and then we obtain L labor demand is K over real wages squared. And in the end, the labor market equilibrium this just means LS equals LD, and then we obtain, where do we have it? Here, L bar minus 1 over real wages squared equals K over real wages squared. Let's put this just up here. And of course, we want to solve for real wages. So putting on one side every parts with real wages. So we obtain L bar is K over real wages squared plus 1 over real wages squared. Then we can take out the real wage. This is then 1 over real wage squared times K plus 1, multiplying with real wages, dividing by our overall time is then real wage squared equals K plus 1 over L bar, and then we obtain real wages squared as the square root of K plus 1 over L bar. And then equilibrium. Labor, just as we have done it also in the ISLM model, we setting in the labor supply or labor demand function, and we obtain then L star is, let's take labor demand, K over square root of K plus 1 over L bar squared, and this looks like then K over K plus 1 over L bar, and in the end L star is L bar times, not this one, no, K over K plus 1. Which then would be our overall equilibrium. Okay, then we are done. And yeah, just have a look here at the review questions. and into the slides, and hopefully, and then we see, or then you can do your exam in January. Thank you very much.